If you have ever opened a computer, you might have come across a module looking like this. This one is a 2 GB RAM module, so 2 billion bytes. And inside the B4 we have a smaller version of this. This one is 16 times 4 bit memory, which is quite sufficient in order to run some of the experimental programs that we've been showing you in other tutorials. What we want to do today is to take a look at what is actually inside one of these chips here. Therefore, we have rebuilt it. So this here is the same as this little chip. What you see here is heaps of LEDs, and we will light them up shortly. But just for brief orientation, this is actually our memory. Okay, and the electronics around it is helping our data to find the way into the memory modules. And these chips here are helping the data to get out so that we can do something with it. Down here we have two variables. This one here is on the left is in charge for our address. So if we turn this knob here, this red light moves up. That is like an elevator. So we are now on the 10th floor. Now we are on the 12th floor, 15th floor, back to floor number 0. That's actually quite a cool elevator that goes from floor 15 back to 0. Can go down, can go up. Okay, so far so good. So this one helps us to go to the right place. This one here, if we turn this knob, it is setting our data. So we can set, for example, that we want data 1 at floor number 0. And all we need to do is to press this button, and that stores the data in the memory cell. So we've just stored a 1 in memory cell number 0. If, for example, we want to store a 2 on the next floor, which is floor number 1. We set a 2 here on the right, that's our data, and a 1 at the address, and then we press the button. Click, now we stored a 2. We could, for example, store a 4 on level number 2. And here we go. Now if you want to complete this diagonal just for aesthetic purposes, we would go for an 8 on floor number 3 and press the button again. We can actually store arbitrary numbers. So if we now want a 15 on floor number 4, we write a 15. If we want to store a 15 anywhere, we just keep this button pressed and then move the floor selector, tuck, 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 and now we have set a 15 on every floor of our data RAM module. This is very cool. Let's look in that more detail. This guy down here does the following. It takes the 4-bit floor address and turns it into an output so that just one single of these chips here is selected. These chips down here take the data coming from these chips and feeding them into the LEDs, and just making sure that we only ever take the data that is coming from that particular floor. So let's just reset this and look at this again. Reset. Great, we've got another button. It's a reset button. So we go down to floor number 0 and write our 1, and then we go to floor 1 and write our 2. Okay, now as we move the floor, if we observe the top here, here's a 1, here's a 2, here's a 0, and that can be turned into a 3. Okay, so these chips here take just the information from the corresponding memory cell and feed them to the output. These are called selectors. Okay, so here's the input and here's the output. This electronic here on the side is just making sure that one of these lights lights up and the right just goes to the right cell of the corresponding memory cell. And that is pretty much a data RAM. So if you want to remember, it consists of an input, it consists of an output, and it has the memory inside. Now all this is of course much more tightly integrated on a chip like this. You can't even see this with your naked eye. Therefore we have rebuilt it for you and you can experiment with it. Works great inside the rest of the B4, as we'll show you next. So here's our RAM module installed in the rest of the B4 computer processor kit. Just to recap, this is our arithmetic logical unit with the adder and the inverter, our little decimal display for output, our latch that holds on to the last result, the 2-to-1 selector which steers data through the computer, and our program RAM, which is the code that the machine operates. So here it will switch on and off components. This one is our automatic programmer, which holds the program, which will then be loaded into the rest of the machine. And down here is our program counter, which gives the steps of the program. Okay, so let's set the program. So we are getting the program now from our Arduino. It is clearing the RAM modules. Now it is setting the data RAM. And now it's setting the program RAM here. So here we have our program. There's a 5, there's a 4, that's a 2. That's an empty slot, so probably the program will store some data into it later. And here's another 5. Let's see what's going to happen. We run the program. First we load a 5. First has been loaded. Then we add a 4. So 5 plus 4. That should be a 9. It is a 9. 9 minus 2 is hopefully a 7, which in this step 7 gets stored in the RAM module. Here's our 7. It has arrived. And the next step is then 7 plus 5, which is 12, which is already waiting to be latched and is going to be stored in the data RAM. Okay, I want to see it again. Let's reset the program. Load 5. 5 has arrived. 5 plus 4 is 9. 9 minus 2 is 7, which is being stored here through this command in the RAM. In the next step, 7 plus 5 is 12, which has been stored into the RAM module. Now, this is happening very slowly, step by step. I'm the clock at the moment. My finger is the clock. But in a computer, this happens much faster. So we can press the automatic button and then pull this jumper. And all this operation happens much faster. So we've seen how the information is stored in the data RAM, how the program counter gives the address input. The rest of the machine works on the actual data that then flows back into the RAM module when it is being stored. Hopefully that was interesting. See you back soon.